Hello. So, dear student, today I will explain you about the application of the calculus in the learning of physics. So, whenever you are going to learn the physics in class 11, so the things are coming like what is derivative, what is differentiation, what is integration, right? So, differentiation means whenever you are differentiating, the power of some equations getting decreased, like differentiation of x cube, we are getting x square. If I differentiate this one, we will get x. So power will be decreased in case of differentiation, right? And in case of integration, like if I am doing integrating x square, I will get x cube. If I am doing integration of x cube, I will be getting x4, right? Okay, so something integrating and differentiating means the power is getting decreasing, right? Now, what are the application in physics of this part? So let me show you. First, you are going to learn like x means the displacement. Okay, so what is the instantaneous velocity? V is equal to dx dt, instantaneous velocity. And what is the acceleration? Rate of change of velocity, that means ddx of dx dt, ddx of dx dt, right? Dx dt. So acceleration means d2x dt2. So this way we are presenting acceleration and this way. So this is the presentation of acceleration. Okay. So now these are the instantaneous velocity, instantaneous acceleration. Now let me show you one application on it. Okay. In class 11, in motion chapter, let's say x is a function of 3t square plus 2t. Okay. Here t is the time variable, x is the displacement. Now the question is that calculate the velocity at t is equal to 2 second. Calculate the acceleration at t is equal to 5 second. Okay, these are the question for you. Now how we are going to solve this? Okay. Now, so I will just do the differentiation of this one, right? So dx dt, dx dt. So velocity means instantaneous displacement, right? The small change is displacement with small change in time. So dx dt, rate of change of displacement. So here it will be d dt of 3t square plus 2t. So it will be d dt of 3t square, then d dt of 2t. Okay, so it's coming 6t plus 2. So this is the expression of velocity. So velocity become 6t plus 2. Okay. Now, so what will be the value of velocity at time t is equal to 2 second? Okay. So v will be 6t plus 2. That means 6 into 2 plus 2. So it will be 14 meter per second. So this is the velocity at t is equal to 2 second. This way you have to solve. Now what will be the acceleration? So acceleration means then now I will do the dvdt. A is equal to dvdt, rate of change of velocity with respect to time. Okay. So it will come ddt of 2t, sorry, 6t. 6t plus 2. So it will be 6. Acceleration is equal to 6 meter per second square. So acceleration is constant. So this is the value of acceleration and this is constant. It does not depend on the time, whatever the time, right? So because ddt of t is 1, fine. Okay, so this way In class 11, the first chapter, you will get this kind of problem. Okay, so you have to solve it by this by this method, right? So this is the mathematical part which you have to be more comfortable. Like sometimes, so you know, right? So ddx of x square is equal to 2x. ddx of x to the power cube is equal to 3x square. This way, fine. Now, next application is on simple harmonic motion. You know the simple harmonic motion, SHM. In simple harmonic motion, we are taking displacement equation like x is equal to a sine omega t. This is an simple harmonic motion equation. Displacement, x is displacement, t is time. This is the frequency, angular velocity, right? This one. Now, and a is the amplitude. So what's happened? So velocity will be dx dt, means ddt of a sine omega t. Okay, so it will come a omega, right? A omega cos of omega t. So this is the velocity. So cos omega t, you can write like aw 1 minus sine square omega t. Okay, so here we are getting v is equal to, okay, a square sine square omega t. I hope you can able to see v is equal to omega a square minus x square. Okay, this is the velocity expression. So we are taking the help of this calculus here, right? I hope it is clear. Now, velocity v is equal to, in case of simple harmonic motion. Fine? Okay. So now velocity will be maximum when x will be equal to 0, v will be omega a. This is in case of simple harmonic motion. Fine. Now next is the acceleration. So what will be acceleration? If this is velocity, now acceleration is rate of change of velocity with respect to time. That means ddt of aw cos of omega t. So it will be a is equal to minus omega square a sine omega t, or you can write a is equal to minus omega square x, right? So this is the acceleration. So let me show you more clearly. A is equal to minus omega square x. This is very important relation. So this we are getting from the, the calculus method. This is the beauty of mathematics over here. One more thing, the differential equation in simple harmonic motion. So A means we know d2x dt2. So here I can write d2x dt2 is equal to minus omega square x, or d2x dt2 plus omega square x is equal to 0. So this is called the differential equation in case of simple harmonic motion. Okay, so these are the application part, okay, of the calculus. Other method like the part of integration, whenever we are going to work done, so work done will come in multiple chapters. So what was the definition of work done? We know W is equal to Fs. W is equal to Fs. Now we will be writing dW is equal to F dx. Okay, small work done for small displacement. We will do the integration. This way we will proceed. So next class I will be explaining all these things. Okay, so get ready. Any question, please let me know. So I will have few series on the the mathematical physics, and this will really help you. Okay, so till that time I will be closing the session for today. Okay.